Study of first element, hydrogen. Here, we'll study about position of hydrogen in periodic table, general group characteristics, different method of preparation of hydrogen, oxidation and reduction reactions. Position of hydrogen in the periodic table. Hydrogen lies in group 1 and period 1 of the periodic table. Resemblance of hydrogen with group 1a elements. Alkali metals have one valence electron and hydrogen has one valence electron. Alkali metals are reducing agent. Hydrogen also is a reducing agent and have strong affinity for oxygen. Alkali metals lose one electron to form +1 cation. Hydrogen also forms hydrogen ion H+1 of unit positive charge. Hydrogen burns in oxygen to form neutral oxide. Alkali metals burn in oxygen to form basic oxides. Different methods of preparation of hydrogen. Hydrogen can be prepared from water, acid, and alkali. Preparation of hydrogen from water. Metal reacts with water to liberate hydrogen. Potassium, sodium, lithium, calcium reacts with cold water. Magnesium, aluminium, zinc, iron reacts with steam. Tin, lead, copper, silver, gold and platinum shows no reaction with water or steam. Reaction of active metals with cold water. Potassium, sodium and calcium react with cold water, producing hydrogen. Metal hydroxides are formed. Reaction with potassium is violent and exothermic. Heat liberated ignites hydrogen. Reaction with sodium is comparatively less violent than potassium. Sodium melts into a silvery globule and darts about water. Reaction with calcium is comparatively less exothermic. Solution turns milky as calcium hydroxide formed is partially soluble. Chemical equations involved in the above mentioned reactions are as follows. 2K plus 2H2O gives 2KOH plus H2. 2Na plus 2H2O gives 2NaOH plus H2. Ca plus 2H2O gives CaOH whole twice plus H2. Reaction with hot water and steam. Magnesium, aluminium, zinc and iron do not react with cold water. Magnesium reacts with boiling water and aluminium, zinc and iron react with steam in the heated system. Oxides of metals are formed instead of metal hydroxides. Reaction of red-hot iron and steam is a reversible reaction. Metals below iron in the activity series have no reaction with water or steam. Chemical equations involved in the above mentioned reactions are Mg plus H2O gives MgO plus H2. 2Al plus 3H2O gives Al2O3 plus 3H2. Zn plus H2O gives ZnO plus H2. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Preparation of hydrogen from acid. Metal reacts with dilute acid to produce hydrogen. Metal activity series. Some metals are more reactive than others. Metals are placed in order of reactivity by comparing how well they react with water or acid or oxygen. The amount of energy given out when a metal reacts gives a measure of its reactivity. The reactivity series places the most reactive metals at the top and the least reactive metals at the bottom. The more reactive the metal, the more stable its compound are. Reactivity series of metal are as follows. Reaction of metal with dilute acid. Potassium, sodium and calcium are reactive metals and they react with dilute acid explosively. Magnesium, aluminium, zinc, iron, and lead are fairly active metals. They show moderately fast reaction and their reactions are comparatively slow. Hydrogen and copper are unreactive metals. They show no reaction with dilute acids. Observation of the reaction. Brisk effervescence is observed. Colorless gas evolved, extinguishes, burning splinter, and the gas starts burning with a pop sound. Reaction of metal and dilute acid. Metals placed above hydrogen in the metal activity series can react with dilute acid. They displace hydrogen from the acid. Salt is formed and hydrogen gas is produced. Metals placed below hydrogen in the activity series are less electropositive than hydrogen and cannot displace hydrogen from dilute acid. The chemical equations involved are Mg plus H2SO4 gives MgSO4 plus H2. Zn plus H2SO4 gives ZnSO4 plus H2. Zn plus 2HCl gives ZnCl2 plus H2. Fe plus H2SO4 gives FeSO4 plus H2. Fe plus 2HCl gives FeCl2 plus H2. Preparation of hydrogen from alkali. Amphoteric metals react with alkali to produce hydrogen. Amphoteric metals. Metal which can react with both acid and alkali. Amphoteric metals react with alkali to form salt and hydrogen gas. Aluminium, zinc, and lead are amphoteric metals. Aluminate AlO2 to the power minus 1, zincate ZnO2 2 minus, and plumbite PbO2 2 minus are formed respectively. Chemical equations involved here are 2Al plus 2NaOH plus 2H2O gives 2NaAlO2 plus 3H2. Zn plus 2NaOH gives Na2ZnO2 plus H2. Pb plus 2NaOH gives Na2PbO2 plus H2. Laboratory preparation of hydrogen using zinc and dilute hydrochloric acid. Reactants here are zinc and dilute hydrochloric acid or dilute sulfuric acid. Why zinc is used? Potassium, sodium, or calcium cannot be used as they react with dilute acid explosively. Copper, silver, and mercury cannot be used as they are less electropositive than hydrogen. Lead cannot be used as lead forms insoluble layer which cuts the contact of the metal with acid. With magnesium, the reaction is highly exothermic, while aluminium is often coated with oxide layer, and with iron, the reaction is slow. Why dilute nitric acid is not used? Dilute nitric acid is a strong oxidizing agent. No hydrogen gas is formed when it reacts with metal. Instead, salt, water, and oxide of nitrogen are formed. Procedure. Gas is collected by downward displacement of water. Precautions. Hydrogen mixed with air forms an explosive mixture in contact of a flame. No flame should be kept nearby the apparatus. Before the collection, some gas is allowed to escape. The end of the thistle funnel should be dipped in the acid. Impurities and their removal. H2S. Removed by passing through lead nitrate solution. Phosphine and arsine removed by passing through silver nitrate solution. Carbon dioxide, sulfur dioxide, and oxides of nitrogen are removed by passing through KOH solution. Water is removed by passing through fused CaCl2 or P2O5. Industrial manufacture of hydrogen, often referred as Bosch process. Chemicals required in this: steam and white hot coke. Temperature required 1000 degrees Celsius. Type of reaction: endothermic. Product formed: water gas, a mixture of carbon monoxide and hydrogen. Reactions involved here: C plus H2O in 1000 degrees Celsius temperature gives CO plus H2. Water gas is mixed with more steam. Ferric oxide catalyst is used here and temperature is given of 450 degrees Celsius. Thus, carbon monoxide gets converted to carbon dioxide. Equation in the above mentioned reaction is CO plus H2 plus H2O gives CO2 plus 2H2. Now, separation of CO2 from mixture of CO2 and H2 is done. The mixture is passed through caustic potash solution or water. Thus, CO2 gets absorbed. The whole reaction of Bosch process is as follows. C plus H2O in 1000 degrees Celsius temperature gives CO plus H2, water gas. This water gas combines with water in the presence of catalyst Fe2O3 gives carbon dioxide plus 2H2. Carbon dioxide here is removed by dissolving in water or KOH. Thus we get pure H2. Oxidation reduction. Oxidation. Addition of oxygen or any electronegative element or nonmetal, or removal of hydrogen or any electropositive element or metal. Oxidizing agent. A chemical that causes the addition of oxygen or nonmetal, or a chemical that causes the removal of hydrogen or metal. Reduction. A chemical process where addition of hydrogen or metal takes place, or a chemical process where removal of oxygen or any electronegative element, nonmetal, takes place. Reducing agent. A chemical that causes the addition of hydrogen or any metal, or a chemical that causes the removal of oxygen or any nonmetal. Let's see some differences between oxidation and reduction. Oxidation is the gain of oxygen or nonmetal, while reduction is gain of hydrogen or metal. Same hand, oxygen is loss of hydrogen or metal, while reduction is loss of oxygen or nonmetal. Redox reaction. The redox reaction is made up of two words, RED, which means reduction, and OX, which means oxidation. Oxidation and reduction takes place simultaneously. Oxygen gets lost by a chemical is gained by another chemical. Hence, one substance is reduced and other is oxidized. Fe2O3 plus 3CO gives 2Fe plus 3CO2. Oxygen removed from ferric oxide, hence it is reduction. Oxygen is added to carbon monoxide, hence oxidation. 4HCl plus O2 gives 2Cl2 plus 2H2O. Hydrogen is removed from hydrogen chloride, hence oxidation. H2 plus Br2 gives 2HBr. Hydrogen is added to bromine, hence reduction. 2NH3 plus 3CuO gives 3Cu plus N2 plus 3H2O. Here hydrogen is removed from ammonia, hence oxidation, while oxygen is removed from copper oxide, hence reduction.